Hello folks, welcome to my YouTube channel. So today let's solve the problem of maximum number of events that can be attended. It's a very interesting problem which leverages the concept of binary heap in data structures and algorithms. So without wasting further time, let's go with the problem statement. So we are being given an array of events where the event I is represented by its start date and end date, and the events can be performed on any single day in between the start time and the end time, and we can only uh, attend any event on a particular day, and we have to tell the maximum number of events which we can attend. So let's go with the problem by the first example. So in this example we are being given an event which starts from the day 1 and 2. For the next event it starts in the day 2 and 3, and for the next event it starts in the day in between 3 and 4. Fine. So as you can see, we can attend the first event in the line represented by yellow. Then the next event we can attend in the line represented in the range represented by orange, and for the next we can attend in the range represented by red. So as you can see, we can attend all the events one after the other in the ranges which we have specified in the example. Now let's look at the example number input number 2. Let's use this whiteboard for better explanation. So yes, so we are being given this inputs. Fine. Now if we try to represent it use in a number line, let's see how what would be the result. So this is my number line. Now this is my first day, second day, third day, fourth day. Fine. Now let's see how we can represent these time ranges. So for the first day, it spans in between this two day fine. The next event it spans between 2 and 3. Now for the next, that is from 3 and 4, it spans in between this range, and for the last it spans in between 1 and 2. Okay, now we have to tell how many maximum events we can attend. Now one thing is very sure, that we can attend events which is having the least time, uh, which arrives first in our place, right? Like now let's say one event appears at 1, I mean the starting date is 1 and the ending date is 3, and there is another event whose starting date is, let's say, 100 and the ending date is 105. Now if you think here, which one we can attend at the very first? Obviously we can attend the one which is having the lesser start time, that is we would be attending the event 1 and 3 at the first, and before the event which starts with 100. Fine. So what is our observation number 1? That perform events having lesser start time and now let's see if there are two events. Okay, let's go by this example only. So so by the first observation, we are performing events which is arriving first. Now out of the ranges which have been given to us, which events are arriving first? It is these two events. Now out of these two we can pick one event at each day. Fine. Now which one we can pick up? Let's say we have picked up this event in day 1. Now what is our current day? If we have picked this up, our current day would become 2, that is we would be focusing on this day. Now let's see at day 2 which all events should we perform. Fine. uh, now till the time we arrive at day 2, which events are present or which events have arrived. If you see, be, by the time we arrive at day 2, these two events have arrived to us. Not sure why it is not writing. Let's just refresh it once. I hope it would write it now. Still it's not writing. Alright, is the right one. Sorry for the delay. So yes, out of these two events, which one should we perform? Now it's very easy to say that the event which is ending at a very less time, I mean before, which is arriving, which is ending before we should perform that, and it is our greedy choice, because the event which is ending at later stages, we can always uh, perform it later on in the future, right? Because that event is not going until and unless it expires. Fine. Now out of these two, I would be choosing this one at day 2. Now what is our current day? It is day 3. Now in day 3, which all events are present to us. The event which are present to us is this and this event. Now out of this, which all out of these two, which all events we should be performing? We should be performing the event which is having lesser end time. So which event is having a lesser end time? It is simply this event, right? Now this event is also done. Now we are at day 4. Now when we are at day 4, which all event have arrived to us? The event which has been arrived to us is this one. So we will be performing this event. Now what is our second observation in this problem? We will be perform event having less end time. This is our second observation. Fine. Now once we have performed all these steps, we should also expire the event. Fine. We should also take care of considering expire the events. Now how we are expiring the events? We would be taking another example. Now let's say our current date is x1. Fine. Let's take it 10. Now let's say there is an event whose ending date is 8, and another event whose ending date is 11. Fine. Now out of these two events, which one we should expire when we are at day 10? Obviously we should expire this event which is ending at day 8, because it's day 10 and we cannot go back in time and perform this event, right? So out of these two, we would be expiring this. And how we can expire? We can basically, okay, so before expiring, let's see how we can perform this event 2, how we can perform this operation 2 or observation 2. We can easily pick up the least element, or the element which is having the lesser end time, by using a min heap of the array. Fine. So we'll be using the min heap to pick the element which is having the lesser end time. Now after we have picked up the element which is having the lesser mean time, we would basically increment our current date. Fine. Now once we increment our current date, we can check from the min heap that which all elements have expired. Fine, and this can be done by just checking the top element of the min heap. If it is lesser than the current rate, we will be simply popping it until and unless the top of element of the min heap is having more value than our current rate. Fine, and we will be continuing this process for each and every element which has been arrived to us. So let's see how we can represent it in the code. So at first, let's maintain a priority queue. Also, we will be sorting the events array. Fine. We would be maintaining a current day, and we would be maintaining our total events. Fine. Now let's also maintain an index. We would be iterating over each and every elements of the events. Make sense? Now at first we would be checking that if our current day, if our current day happens to be more than the events which more than the events at the current index. I mean more than the start day of the event. At the current index, in such a case we will be pushing it into our priority queue. So what we'll be pushing? We'll be pushing the end date into our priority queue. After that, what we'll be doing is we will be popping the element which is having the least enter time. Simultaneously, we will be incrementing our current date, and we would be incrementing our total day. Fine. Now after this is being done, we have to expire the events which has been already been completed. So how we can do that? We would be simply checking the the element which is at the top of the priority queue. If it is lesser than the current day, we would be simply doing priority queue dot pop. Now we have to consider few things. That is, initially our priority queue is having a size of 0. Now if our priority queue is having a size of 0, uh, let's think what does it mean. At the first, we are having a priority queue size of 0. Now when can we have a priority queue of size 0? We can have a priority queue of size 0 when our current day is when we are pushing into a priority queue. Let's think that first. So we are pushing into a priority queue when our current date's value is more than the index we are at for the events. Now let's think of this scenario. mm, let's say uh, yeah sorry let's say we are having this range, and some ranges like this. Okay, let's take it day 1, day 2, and this is day 100. All right. Now initially my current date would be 1, then it would be 2. Now what would be the next day? It is at day 100. Fine. So by this time, by the time we look for 100, we would have already performed these two operations and popped everything from our priority queue. Fine. Now we need to push this 100 into our priority queue, right? Because this is our next element. So we would be having a check uh, on the size of the priority queue. If our priority queue is having a lesser size and we have still few elements to process, in such a case we should be updating our current day to the next day. Makes sense? And also we should consider one more situation. Let's say we have exhausted all the events, or we have iterated all the events, but we still have some elements in our priority queue or which have already came to our queue basically, right? So we should also process those elements one by one. Makes sense? So we should also have a check on the size of the priority queue and continue till the time we have any elements in our priority queue. Fine. So after performing these steps, we should be getting our correct answer, and what we will be returning is we will be returning the total events. And let's quickly run this code. Yeah, it is running on the test cases given to us, and yeah, we are able to submit it. So yeah, so that's it for the video. So see you next day. Thank you.